In this video, we're computing the integral of x squared times the quantity 2 minus x cubed, all raised to the 100th power. And we're going to start by doing this in an informal way by seeing the chain rule backwards, and then we'll show how to do it with a formal u-substitution. So for the informal approach to this thing, what we need to recognize is that by having an x squared out in front of this 2 minus x cubed to the 100th, we basically have the derivative of the interior function of a function composition. So the interior function here is 2 minus x cubed. The derivative of that is negative 3x squared. So we can just provide that to our integrand as long as we compensate out in front by multiplying by negative 1 over 3. So the 1/3 tags along at the next step. And now that we have the derivative of the interior function right next to this function composition, we can quickly guess the antiderivative. We just apply the power rule to the function composition. So I end up with 1 over 101 times the quantity 2 minus x cubed to the 101 plus c. And anytime you're using the chain rule informally like this, it's wise to at least mentally check that the derivative gives you back what you started with. So when I think about differentiating this, a 101 would come down in front and cancel the 1 over 101. We'd subtract 1 from the exponent and end up with 100 for our exponent. And then the chain rule would say, well, now you have to tack on the derivative of the interior function, which is negative 3x squared. And that's right there next to the 2 minus x cubed to the 100th. And so we can see that we've guessed the correct antiderivative. Finally, we should probably clean things up a little here. And I'm going to write this as 2 minus x cubed to the 101st power divided by 303. And there's a minus sign out in front of it. And don't forget to put a plus c on there. So next we're going to look at the formal u-substitution approach to this integral. And to get this done, you still have to basically see that you have the derivative of the interior function hanging around, at least the correct variable pieces of that. Otherwise, this isn't going to be fruitful. So we notice in advance that we have this x squared sitting around, which is essentially the derivative of the interior function. So u-substitution is a promising approach here. So we're going to let u be equal to the interior function 2 minus x cubed. And this means du is the derivative of that, negative 3x squared, multiplied by dx. And this means dx is du over negative 3x squared. So we make all these substitutions into the integral. And we have an x squared times u to the 100th, just replacing 2 minus x cubed with a single u. Then dx is du over negative 3x squared. And then we're relieved to find out that the x's cancel. Now that's essential because you can't do the integral unless it's entirely phrased in terms of a single variable u. And of course, the reason those cancel out is because we basically had the derivative of the interior function hanging around in the integrand. Now I can pull the negative 1/3 out in front of this, and we end up with negative 1/3 integral of u to the 100th du. So we can use the power rule on this guy, and we get negative 1/3 times 1 over 101, u to the 101 plus c, and we're not done yet because this was an x integral. So we have to replace u with its definition in terms of x, and that's just 2 minus x cubed. So cleaning things up, we end up with a negative 2 minus x cubed to the 101st power divided by 303 plus c, and it's the same answer we got before, so we're happy. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.